Alright, hey everyone, this is the solution for day 17 of Advent of Code. And today was an interesting problem again, some shortest path finding with some rules on how we can move. So let's have a look. What our input is a grid of integers, and each integer tells us the heat loss at a particular position. So for example, this 4 tells us if we enter this position or go through this position, then we'll have a heat loss of 4. And we're gonna want to go from the top left corner to the bottom right corner with the lowest heat loss possible and want to find this path. However, we cannot just move arbitrarily. So there's two things which are not allowed. So first, we're not allowed to turn around. So if we enter a position from a particular direction, we cannot go back in the opposite direction. And the second rule is we're not allowed to do more than three moves in the same direction. So we are only allowed to do 1, 2, or 3 moves in the same direction, and then we have to turn. So for example, for this test grid, the optimal solution would be this. We never go more than 3 steps in the same direction before we turn. And we reach the bottom right corner. Okay, so how can we do that in code? So what we will do, of course, with the grid, so we'll have a position to make our moving around easier, and then we code up the code for adding 2 positions and checking if 2 positions are equal and so on. And then we'll represent the input as a grid that's a dictionary from a position and integer, and we find this from the input by just enumerating all the lines and then enumerating each single line, which will give us the coordinates in order to fill the grid. And in order to move around, we'll have a notion of the 4 main directions, north, south, east, and west, and we also have and this will be an enum, and the values will be at 1 step in the corresponding direction. So this will be taking 1 step north and taking 1 step south and so on. And then what we want to do is we go for each position and consider all the possible next positions, and with this go through all possible paths and until we reach the end position. And in order to do that, we don't want to use some random order, but we always want to consider the most promising path. And the most promising path will be the path with the lowest heat loss. For that, we will use a priority queue to always give us the state with the lowest heat loss. And in order to fill the priority queue, we'll have this notion of a state. So states first will have an order. So we want, as I said, we want to always consider the state with the lowest heat loss. So we have this, use the data class with this order to set to true. And what we compare is only the heat loss. So we don't compare position and previous direction. And so we set them to compare equals false. Yes, and so a state is kind of all we need to know. So if you're at a particular position, we do not need to know how we got there, but we only need to know what the current position is. And since we have these rules that we're not allowed to take more than 3 steps in the same direction, we also need some notion of what the previous direction was. So we know which directions we're allowed to continue moving. And since still like considering the states, even if it's ordered by heat loss, it still gives us far too many possibilities. So we want to not consider some state. So in particular, if a state has the same position and the same previous direction as a previous state, then it's no point considering it, because since we see it later, we will have a higher heat loss. So it's just strictly worse than the previous time we saw it. So we want to compare states if we've seen a state with the same position in the previous direction. If those 2 values match with a previous state, then we don't need to consider a state and we can just ignore it. Okay, so that's for the notion of a state. And with this, we can find the shortest path. So we have our input, our heat loss grid, and we have a starting position and a goal position. And then the first state will be starting position. The previous direction will be none. We have not moved yet. And the heat loss starts at 0. And then we have this priority queue, which will always give us the state with the lowest heat loss. And we'll go through the priority queue. So we also keep track of all the visited states. Okay, then each step we will consider get the state from the priority queue. And then first we check if we've already seen a state with the same position and the same previous direction. In this case, we ignore this state. Otherwise, we of course need to add it to the we need to add the visited attributes of the state to this set of visited states. The next thing we check is if the state position is equal to the goal position. That means we're done, and since the Q is ordered by the heat loss. We know that this is the smallest heat loss that allows us to get from start position to goal position. So we just return the heat loss of the current state as the solution. And then finally, if none of these are true, we need to take steps in all possible directions and enqueue the new states. So we go through all these possible new directions, and then we'll also go through the possible number of steps, which will be 1, 2, or 3. And then we move in this direction with this number of steps to give us a new state. As a last check, we need to check if the new state position is actually legal position. So if it's in the heat loss grid keys. If this is the case, we are good, and we add the new state to the queue. And then we'll continue and always get the state with the lowest heat loss from the queue until we get the state with the correct goal position. Yes. The new function we needed is this function to get all possible new directions. So based on the previous direction, so if the previous direction is none, if at the start any direction is possible. Otherwise, we're only allowed to turn at a particular position. So if the direction is north or south, we return west and east. And otherwise, if the direction is west or east, we return north and south. And in order to move in a particular direction for a particular number of steps, what we do is we just iterate we just count the number of steps, and each time we'll add the direction value to get the new position. And then for this position, we found out the heat loss at that position and add it to the heat loss for the move. And here we have a default of 0 in case we leave the grid, and we handle this case above actually. Okay, so then we can define the new state. We'll have the new position. The previous direction will be this direction from the move, and the heat loss will be the previous heat loss plus the heat loss from the move. And then return that. So that's all what it takes us to find this shortest path, or this path with the lowest heat loss. So we can solve the problem. So we pass the input. The starting position will be the position 0, 0. The goal position will be the position with the max x and y coordinates. And then we call this find shortest path to give us the shortest path and the heat loss corresponding to the shortest path. That would be a solution. Okay, we should try that solution on the test input. And that looks good. So we also run it on the real input. It does run for about a bit less than 10 seconds, but it also gives us the right solution. For part 1, we need to adapt our solution. So they changed the rules a bit. So for the new vehicle, we only allowed to do different number of steps. So we have to move straight for a while, but we can't move straight for too long. So particularly the number of steps will be anywhere between 4 and 10. So this is the only line we need to change. And with that, we can solve the problem as part 1. And if you run it on the test input, it does give us the right solution. So we can also run it on the real input, and it also gives us the right solution. All right, that's it for day 17. I hope you enjoyed that puzzle. Best of luck in the future, and I'll see you around.